Today I'm going to demonstrate how to use Kubetorch to build a retrieval augmented generation app. The app supports endpoints for adding documents into a vector database and then generating a response to a question using the additionally provided documents. To do so, it makes calls to an embedder and a llama model, and these are each deployed as independent Kubernetes services using Kubetorch. Before we dive into the example, let's quickly go over some of the challenges of building and scaling such composite inference apps, which involve handling multiple models in one single pipeline. For starters, we have the one pod deployment, where all the underlying models are being run on the same pod as one deployment. This leads to resource bottlenecks and lack support for autoscaling or queuing. Then we have frameworks like RayServe that do let you break apart the components. However, there's still no ability to specify separate images or hardware for the different components, and this often leads to it being resource constrained, and also you end up having to debug version mismatches across your different services. Docker Compose lets you use a different image for each service. However, it does not support GPUs in local mode. Or you could build multiple services yourself on native Kubernetes, but every time you want to make and test a change, even if it's only for one single service, you find yourself having to rebuild and redeploy everything. You also end up testing through port forwards and tunneling, and this also gets messy. Kubetorch combines the best of all worlds. It supports fine-grained customization and control of images and hardware. This is specific to each service. You deploy and iterate on each service independently, and changes are hot synced, and each iteration loop is on the order of seconds. Autoscaling and queuing support is also built in. The models and services all work together. They're all able to interact and call on each other. And as a bonus, these services are modular and you can reuse them across different applications as well. To summarize the example, we have a Python file containing the definition of an embedder class, a llama class, and a FastAPI app. We use Kubetorch decorators to wrap the classes and use the ktdeploy CLI command to deploy them as knative services with autoscaling. Then we use the ktrun CLI command to start a FastAPI app in Kubernetes as well. This FastAPI app is able to directly import and reference the other services that we launched, and it also has endpoints for adding a URL and generating a response. Lastly, we use kt port forward to use the app from our local environment. Now let's take a closer look at the code. Here we have a standard embedder class with the embed function, and we see that it has the kt compute and kt autoscale decorators. The kt compute decorator specifies the resources and image that we want to deploy the service to. So in this case, we have one GPU and we specify the image PyTorch Docker image, additionally installing sentence transformers on top of it. The kt autoscale decorator just specifies the autoscaling config that you want. Similarly, here we have a llama class with a generate function, also with a kt compute and kt autoscale decorators. You can see that the compute and autoscaling config for the llama class is different from the embedder class, so each service or each class that you construct, they can have their own compute and autoscaling configs. Now that we have these classes, we can just use the ktdeploy CLI command to deploy them as Kubetorch services. Ktdeploy, and we pass in the name of the file, ragapp.py. What happens here is we go through the file and look for any classes or functions that have the kt compute decorator on it and deploy those as services. The first time that you deploy these services, it might take a couple of minutes to pull the Docker image, do any additional installations, and also download any models. However, as you can see here, on subsequent iterations and deployments, it takes place in the order of seconds. What happens here is that you can make any changes locally to your classes, image, and when you do redeploy, we simply hot sync over the changes and update it remotely. Once your service has been launched, you can use it as you would any other Python class. Let's import our embedder class from our rag app and recall our embed function. We can just call it with embedder.embed and pass in a test sentence with normalized embeddings. This will make a call to our service and stream back the output and any logs. And now moving on to our FastAPI app, which makes calls out to the embedder and Llama model classes and uses a LanceDB vector database underneath to store the embeddings. We start off by defining the FastAPI app, setting up the Lance database, and also with some prompt formatting. Here we define a KT app object. This is used to deploy our FastAPI app as an app on our Kubetorch server. This app is only used in conjunction with the kt run CLI command. If you just run any other normal command, we ignore it and don't actually deploy this file. I'll discuss that a little bit more in a bit. Now, defining these endpoints, we have our health endpoint. We have an add endpoint, which generates embeddings for the URL that you specify and writes it to the database. Here you can see that we call the embedder class that we just defined, and we call its embed function. We also have a generate endpoint that generates a response to the question that you give it. You can see here that we're also making a call to the embedder service that we deployed and also to the Llama service. So you can run this as a normal local FastAPI app, calling FastAPI run ragapp.py, and this will just deploy it as a normal local app. You can iterate on it, do all your debugging, and wait until you get it in a good enough shape. And once you want to deploy it onto Kubetorch, you can append the kt run command. You see that it's deployed our FastAPI app as a Kubetorch service. And in order to interact with the service, you can run kt port forward. This creates a port forward to our RAG app, and because we use the KT app definition, it also includes a port forward to our FastAPI app. And now we can run curl commands through the service just as we would with any normal FastAPI app. Here we're passing in the path our VLLM Llama 3 inference example, and just one thing to note with the URL is that we add an additional HTTP to the endpoint, and this signals that we want this command to be passed through to the FastAPI app and not just to the service. See that it succeeded, and now let's run with the prompt. How do I deploy with Kubetorch? Says we can deploy with Kubetorch by using the kt deploy command, which allows you to deploy models, datasets, and other assets to your Kubernetes cluster. It also specifies the source as the Llama inference that we just passed in. Thanks for listening.